Hello, welcome to a new video. In today's lecture, we're going to talk about Spark, which is an open source framework designed when we have big data. Okay, so if you remember in previous videos, we covered Hadoop MapReduce, and when we're working under that framework, it takes like more code. You need more lines of code, a more low-level code in order to perform some basic analytics. Now, in the case of Spark, this one is a little bit more modern. So it looks similar to the tools that you have used in your data science courses. So you will use like some functions that look like pandas. So in some cases, they are similar to scikit-learn depending on what you're doing. So the key attributes is like it's fast. Sometimes it's like faster than a MapReduce, like 10 times or even up to 100 times. And in general, it's a high-level language that is going to be, in general, simpler to learn. So why we're going to use Spark and not our traditional tools? Well, what you need to think is like imagine that you are dealing with big data, so you have a cluster instead of a single machine. So you have like multiple nodes. So Spark is designed to perform operations in parallel. So our traditional libraries, they were not designed for this type of computations. So that's why Spark it's important when we have big data and when we have distributed storage and distributed processing. So traditional tools won't work, and that's why we are checking these frameworks. So the nice thing is like we can use like Python, Java, R, different languages. So in Spark, you will find basic analytics. Also, there are some libraries for SQL, streaming data, and especially for machine learning. Since we have again data in different potentially we'll have data in different nodes. So the way in which we arrange the data is different. So we cannot use the traditional machine learning libraries, and we need more specialized libraries in order to get some benefits of parallel computing. Think about it. It's like remember when you have like GPU and CPU. So when you are like when you wanna use the GPU in your computer, or if you're using Colab for example, then there are some advantages of parallel computing, right? So same idea here. Okay, so there is a comparison between MapReduce and Spark. So again, I already mentioned some of the benefits and differences. So in the case of Hadoop MapReduce, you need to the programming is longer. You need to create some functions for the mapping and for reduce. In the case of Spark, as you will see in this video, but where we're gonna I'm gonna show you some basic functions of Spark. You will see it's more natural to like compared to the things that you have learned before. What else? The performance. So that's where Spark shines. Again, it's like between 10 or 100 times faster than a traditional MapReduce. So that's like more than enough arguments to change it, right, to this framework. The learning curve in this one is simple, I would say. Okay, so let's go over a quick example where you will see some of the functions. So here, even though I'm using VS Code, I installed there is a Colab extension. It's new, actually. It was released in November 2025. Well, that will depend on when you're watching this video. So the nice thing about the extension is if you're using Colab, you know that you can access to a GPU, free GPU, right? And if you have like an academic version, like academic pro, then you will get more benefits, of running using their infrastructure. All right, so I'm using Colab here. It's simple. Once you install it, it's just in the kernel. you can access to, like a Colab kernel, and that's it. All right. So let me show you. The first thing that we're doing here is that we're installing a PySpark. So it's this like Spark version for Python. It will take some time the first time because it's like a 400 megabytes library, because it's installed kind of like a local Spark version. All right. So once we are ready, we need to initialize a Spark session. So this is important. This is where you connect, like with in this case, it's a local machine. It's like a single machine. But here, if you have, like a cluster, you need to connect to the cluster. Or if you're using a, cloud service, again, you need to have the way to connect to that cluster in Azure or AWS, depending on what you're using. All right, so once we're connected, it shouldn't take that long. So let me just show you some basic functions using Spark, and you will see that they look similar to pandas. So here we're creating some data, some transactions for a electronics retailer. So here we're creating the data frame using Spark. So there is nothing weird here, right? So you can visualize the data. And there are some basic operations. So we can describe our dataset again that looks like pandas again, but it looks a little bit different, but at the end it's same idea. So now, just to repeat this, maybe you're thinking, so why should I use Spark and not just pandas? The things like pandas and similar libraries, they were designed for a single machine. But if when you have big data and you're distributing your data, like in different nodes or different machines, different servers, then the traditional libraries won't work. They are not optimized for that. So Spark is optimized for parallel computing. It knows how to handle data that is distributed, in different storages. So that's why it's a good framework to know. Okay, so we can compute, like add new columns. So here, creating new columns. We're just multiplying price and quantity to get revenue. So there is nothing weird, right, about this. Now you compare, these operations with MapReduce. Remember from our previous week, if you go over the video, in order to just count something, it takes, like you need to define a couple of functions, add way more lines than this. This is more like declarative. It's more similar to what you have done before with pandas and similar libraries. Okay, we can filter data, filter function, and add some conditions here just to see one category, electronics, for example. We can aggregate to get different metrics. For example, here where we have a group by category. So we have here electronics, clothing, home, and then we are aggregating to create some metrics: revenue, we're going counting, and the average revenue. So these are the columns that we're adding here, right? Some metrics. We can also order or group by country in this case. So yeah, you get the idea on how this works. The top selling products, and you can order by and perform different operations, which you can go over, like checking this notebook. Okay, I mentioned before that Spark, there are libraries for SQL, which is very useful. So Spark will be able to make that interpretation for you and get the queries, even if you are in a distributed big data scenario. So let me show you some of the examples. Here we're trying to get high value transactions or values or transactions that are greater than 2,000. So with the query number 1, we're using Spark SQL. So we select the fields that we want to get from the table sales, where revenue is greater than 2,000, standard SQL. So this is, standard SQL. So you get the result. Again, the difference here is that all these functions are optimized for big data and for a distributed scenario where you have your data in different nodes. Okay, so we can go over the other queries, and the idea it's similar. So you want a category performance summary. So select the category, that's our query. And we get some metrics. We want to count, we're going to get the sum of revenue, the average revenue, the max revenue from sales, right? And we want to group that by category, and we want to order by descending revenue. So this is the table that you get, right? So you can go over the other examples. Again, this is just standard SQL using Spark, right? That's what you're learning in this video. So once you finish with the code, you need to stop the Spark session, right? So the engine stops working. If you are using like the Spark installation on your computer, it has also like an interface where you can see what it's doing. It's simple that you need to keep track of all the works that are being performed in parallel. In our next video, we will cover like machine learning. We will focus more on how to create a regression model, a classification model, a clustering model using Spark. Because again, the structure of the data, it's different in that case. Okay, I'm gonna stop the video for now. I'll see you in our second video.